Hello friend, in this video I will try to explain assembly line balancing in short. So what is assembly line balancing? So we split this word. So first word assembly, that is nothing but joining of two or more parts in workstation and form a finished good. Then assembly line means a semi good product flow from one workstation to another workstation, and each workstation there is a addition of their required component, and finally we'll get desired components. Then there is a certain main objective of line balancing. So why we required our main objective? First, that is to equalize the workload among the operator. Most of cases it is happen that um, most of workload or percentage of workload not equally distributed among operator. Maybe most of work loaded on unskilled, and somewhat less percentage of workload or loaded on skilled labor. So this problem we can minimize by using line balancing problem. Then next objective to identify the bottleneck operation. So bottleneck operation is nothing but a maximum time required a particular event or activity in cycle. Then in this by line balancing we identify that particular operation and try to minimize that cycle time of that particular event by applying certain methods. Then to establish the speed of production line, so we can maintain assembly line, production line according to requirement to manage our fulfillment. Then to determine the number of workstation. So the line balance main objective of line balancing, that is to identify the number of workstation. If we minimize workstation, means ultimately we can minimize resources, that is man, machine, and maybe use of electricity. Means ultimately production cost can be minimized, and customer get product in cheaper rate. And next objective to determine the labor cost of production and pack out. Then to establish percentage workload of each operator. So if workload is maximum of any particular operator, so we can minimize that and balance it. Then to assist in plant layout and to reduce production costs. So these are the main objective of line balancing. Then I can explain this all with a simple example. Suppose we have four activities for produce a single component, that is activity 1, 2, 3, 4, and required time, that is 15, 15, 15 and 10 minutes. Means we can say that if you consider maximum time of any event, that is 15 minutes, means after 15 minutes each component will produce. So for this problem our bottleneck time is 15 minutes or cycle time is 15 minutes. So we can minimize bottle time or cycle time by avoiding overburden or minimize the 7 mistake, that is defect, overproduction, transportation, waiting, inventory, motion and processing, and reduce variation if variation regarding change of product. Then some terminology used in assembly line balancing, that is bottleneck. The workstation taking the longest time. There is a difference between workstation and activity or event or task in cycle. So workstation may be having more than one or two tasks. So our ultimate objective to identify that bottleneck means longest time required for workstation, and if possible minimize that. Then required cycle time, this is a theoretical cycle time, that is total time available upon required output. Means suppose we have 8-hour shift, that is available time, and we required 100 unit or demand of customer, so required output that is 100. So 8 hour converted to second and divided by 100, so we'll get take time. Then current cycle time, that is actual time or in operational condition, the same as bottleneck time. Means bottleneck, that is maximum time required for any workstation. Then flow time, or also called as a total work content, time to complete all station. Means flow line is nothing but summation of all activities or tasks in cycle. So for example, activity 1 2 3 for any particular cycle having 2 minutes, 5 minutes and 3 minutes. So flow time is nothing but summation of all time 2 5 3, that is 10 minutes. Then current cycle time, that is maximum time of any task. So here 5 minutes, or we consider bottleneck, means after 5 minutes one product can produce. Then next terminology is precedence diagram. So precedence diagram is nothing but it's showing order of tasks and restriction on their performance. Means this diagram represent preceding activity and successor activity. Then time required, if any one activity hampers, then what effect on successor activity or total cycle time. Then next terminology, that is total work content, sum of the task time for all the production tasks for the product. Means from beginning to end, how much time required, or total time required to complete that product. Then minimum number of workstation, how to find minimum number of workstation, that is total work content or total time summation of all task time upon cycle time. So the quotation should be rounded to the highest next integral. If workstation we can calculate, suppose we find 4.5, so we consider next higher integration value, that is 5. We not write workstation in point, that is 4.5 or 4.6, so we should need to round up it. Then a simple step of line balancing. So first step, that is identify tasks whose preceders have been assigned to a workstation available task. So on the basis of precedence diagram, we can identify preceders task. And next step, determine the available tasks whose those that fit and those whose take time remaining to fit at this workstation. Means after calculating time required to any workstation, so club respective tasks to fulfill that workstation time. Then third, choose a task that fit by some decision rule. Means for we consider largest time, most successor and greatest sum of tasks time to. So all these step I think clear from one example. So we consider first one example, so you can clear these all steps. So we consider a small example for line balancing. Suppose we have number of tasks from A to H, then their respective time in second, such as A 70. Then preceders are given. Means B, C, D, E cannot start before A, like that. Then wanted total product is 320 unit per day, that is demand of customer. Suppose theoretically, if you consider maximum time, that is time required for task B is 80. So maximum workstation time, if you consider 80, so A having 70, B 80, Then C and D can we club, that is 40 plus 20. We cannot club E because summation is more than 80. So our limitation is 80. Then we can join E and F, summation 70, G 50 and H 50. So this is case, we can say case number 1. We prepare here 6 workstation for 320 unit per day. So according to case 1, or we can say current condition, current cycle time or bottleneck time, that is 80, because B having maximum task time, that is 80. So we consider this as a bottleneck time. Then current number of workstation required, that is 6, and total product per day according to time availability and cycle time we can calculate it. So total product per day, that is 360 unit according to current condition. Then according to problem statement, if you solve by using our method, so cycle time, again same formula we can use. So this total per day unit we shift on 80 and 80 shifted towards right side. So in this way, means if you know the how much quantity to be produced, so on that basis we can calculate cycle time. Then maximum cycle time, that is 90 seconds for each workstation. So total work contain 380 seconds. So summation of all these tasks is 380, means we have now cycle time 90, total work contain 380. So we can find out or calculate number of workstation required, that is 4.22 only, and if you round up, means maximum 5 workstation needed in second case. So if you plot precedence diagram, so B, C, D, E start after A. So this diagram can be formed by using our statement or problem statement. So this is precedence, means these activities start after this, F start after B and C, then G start after C, H start after D, E, F and G. On this or by using this we can plot this precedence diagram. So we can say this is stage 1, stage 2, stage 3 and stage 4. After that, how to place tasks in each workstation. So mathematically we determine 5 workstation, station 1, 2, 3, 4, 5. So how we will place each task in that workstation. So maximum capacity, we can say capacity of each workstation, that is 90 seconds. So start from A, then A, that is 70. So we have only a scope of 20 seconds. So start from B, 70 plus 80 more than 90, 70 plus 40 more than 90, 70 plus 20, yes, we can fulfill, that is condition 90 seconds. So workstation having A and D, that is 90 seconds. Similar way we can fulfill another workstation also. So C plus G, we follow a rule, that is a workstation not more than cycle time, means workstation having tasks not more than 90 seconds, as well as we consider most successor tasks for fulfillment. So we not directly jump on A plus H or A plus G. So we check one by one. A plus B, no, then C, no, then D, okay, then E, then after fulfillment we consider B, then F, like that. So according to that, workstation having A, D, then 2 CG, 3B, 4EF and 5H. Summation not more than 90. And this is a chart prepared, that is a task time 70, task time plus follower time, that is 380. So maximum time required to complete product, that is 380. Suppose E having any problem, then 90 means 90 seconds remaining to complete a product, means this is time duration. What happen if any one task is hampering? So when you compare, means case number 1, that is current condition, cycle time that is 380, and we have 6 workstation according to 80 cycle time. So line efficiency is 79, means this is our current condition having 1, 2, 3, 4, 5, 6 workstation. And in second condition we have only 5 workstation with cycle time 90. So we can see that there is a difference between efficiency 79 and 84. So ultimately we decrease workstation and increase cycle time of workstation, and we can increase efficiency of line by 5%. So our main objective to increase efficiency, not a production. So efficiency increase means you can use or you can properly utilize your resources. So this is a simple example for line balancing. And then we jump on theoretical background of line balancing. Then assess assembly line classification on different characteristics, such as product characteristic, maybe a single model or mixed model or multi model, means one product single model, that is one product flow on assembly line, or multi model, that is number of product flow on assembly line. Then workflow characteristic, pace, unpace. Then assumption characteristics, simple or generalized. Layout characteristic, series, parallel, U, means series workflow from one workstation on another workstation in single line, maybe parallel 2 lines. U means forward and reverse, such that objective characteristics, single and multi-objective, maybe having only assembly line, or maybe multi-objective assembly plus maybe manufacturing, then or manufacturing plus assembly. Then task time, maybe fixed, variable, and stochastic, sorry. So that depend upon production system. Then method of assembly, first that is manual single station assembly, means it consists of single workplace and operation done by manually. Then a manual assembly line, it consists of multiple workstation, and each workstation having one or more workers to perform a task. Then automatic assembly system, here use of automatic method, maybe use of robots or automatic machines. Then again there is a two type of systems, that is non-mechanical transfer and mechanical transfer. So non-mechanical transfer means hand-to-hand or use of human beings. Problem phase, that is wait for part from preceding station if your current task complete before time. And second problem is wait for next operator to finish the task before passing along the part. Means there are two possibility. If your current task is complete before time, then first you need to wait for preceding station, and second possibility, you wait for next operator to finish that task. So second method, that is mechanical transfer or use of conveyor. Same problem arise and unable to finish the current part properly. Then impact of using unbalanced line and second, that is impact of using balanced line, means basic difference between unbalanced and balanced line. So if you consider unbalanced line, there is a high workload in some stages, that is overburden on particular machine or operator. Then maximize, there is a chances of maximum wastage, maybe over processing, inventory, then waiting, rework, transportation, motion, that is 7 type of waste. Then maybe there is a high variation from product to product. Then restriction, one piece flow. Then maximum idle time, if some stage having overburden, so obviously there is a chances of maximum idle time in another stages or tasks. Then obviously poor efficiency, we already clear this point by using one example, that is a traditional 79% efficiency, and if you properly work on by using a certain method, so we can improve that line efficiency up to 84%. So these are the maybe limitation or disadvantage of unbalanced line, and we can same problem improve by using line balancing. So impact of using balanced line, that is promote one flow, piece flow, avoid excessive workload in some stages, minimize wastage, reduce variation, increase efficiency, minimum idle time, because we distribute load among the operator or worker equally. Then after reverse discussion, need of balancing line or assembly line. So all needs are correlated with objective to meet customer demand. So what is customer demand? So customer required product within time, with quality, and with low cost. So if your line balancing done very well, so your production cost or product cost obviously minimize. To determine the speed of assembly line, to determine the number of stages or number of workstation, then to identify the bottleneck stages of operation, then to equalize the workload among the workstation, and to reduce the production cost. Then last, up to conclusion part, solution of line balancing problem. There are number of scientific methods, that is large candidate rule, Tilbridge, Wessner methods, then rank, positional, weighted method. So these three methods are mostly used to determine the number of workstation. Then there is a simple method in line balancing also. So divide work element or divide workstation according to cycle time, then change speed automatic station. These are the trial methods, or we can change methods. Pre-assembly of components, then inventory buffer between stations, and we can use parallel station, means at a time we can use 2 or 3 same machine instead of a single machine. So these are the trial methods, error and trial methods. So in this way we can conclude our topic. I hope so you will enjoy this video. Thank you. Hello everyone. In this video we will see a main topic of industrial engineering, that is material handling system. So in short, a basic meaning of material handling system is a movement of material from one place to another place effectively. Effectively means with low cost, with low time, or right place. And there are so many factors which we consider for material handling. So material handling is primarily related with movement of bulk, packet, and individual material to facilitate operational within limit of organization and plant. Then material handling deal with preparation, placing, positioning of material to facilitate their movement or storage. Then it is an art and science involving movement, handling, and storage of material during different stages of manufacturing. So material means maybe raw material, same finished product, or maybe finished product. Then the scientific material handling result in significant reduce in cost and production cycle time. A non-productive but necessary activity and which account for huge proportion of total cost as per product. Then what is the purpose of material handling? So material handling works is quantified in terms of amount of material, maybe in terms of volume, number, means quantity, and weight. So move from a distance. Then material system should deliver, means main purpose of material handling system is placing of uh, or delivering material with right amount, with right material at right place, and then at right time, at right sequence, then using right method and at right location and at the right cost. So these are primary parameters for ideal material handling system. Then there are various principles of material handling, such as planning principle. All material handling should be result of deliberating a plan where the need, performance objective, and functional specification of the purpose method are completed defined as the outset. Second principle, that is standardization of principle. Material handling method, equipment, control, and software should be standardized within the limit of achieving overall performance objective and without sacrificing needed flexibility, modularity, and throughput. Then third, that is work principle. Material handling work should be minimized without sacrificing productivity or the level of service required of the operation. Fourth one, that is ergonomic principle. It related with human capability and limitations must be recognized and respected in the design of material handling tasks and equipment to ensure safe and effective operations. Next, unity load principle. So unit load shall be appropriately sized and conformed in a way that achieve the material flow and inventory objective at each stage in the supply chain. Next, space utilization principle. That is effective and efficient use must be made of all available cubic space. Cubics means all three dimensions available space. It should be properly utilized. Then system principle. Material movement and storage activities should be full integrated to form a coordinate operational system which span receiving, inspection, storage, production, assembly, packing, order selection, shipping, transportation, and handling of returns. Eighth principle, that is automation principle. A material handling operation should be mechanized and or automated where feasible to improve operational efficiency, increase responsiveness, improve consistency and predictability, decrease operating cost, and to eliminate repetitive or potentially unsafe manual labor. Ninth, that is environmental principle. Environmental impact and energy consumed should be considered as criteria when designing or selecting alternative equipment and material handling. 10th, that is life cycle cost principle. Throughout economic and analysis should account for the entire life cycle of all material handling equipment and resulting system. So hence material handling integrate the process for smooth flow of subject, man, material, machine such that it reduce extent of movement, accident, production cycle time, space requirement, delay, and cost. Uh, there are several category of material handling equipment, such as bulk material machines, then elevating machines, hoisting machine, and monorails for convey of raw material. Then material handling equipments such as conveyor, screw belt roller, then cranes, include jeep, bridge, cranes. Then hoist include chain, maybe chain type or electric type. Then industrial vehicles, that is such as fork, platform. Then chutes, then motor vehicles, then railroad cars, marine carriers, and containers. Then there are various type of material handling equipment. So figure shows. Then move towards concluding part, that is selection criteria or parameter deciding for material handling system. So first characteristic or criteria required, that is characteristic of material, that depend upon size, shape, type, and form of material. Then next, layout and type of building, that is maybe we consider product layout or process layout or job or fixed type. Then amount of material to be moved, means how much amount, maybe small size or big size. Then nature of movement, that is maybe continuous or intermediate. Then orientation of movement, it include vertical or horizontal or inclined. Then direction of movement, that is fixed or changing. Then engineering factor, including ceiling, then columns, structural strength, and last, that is main factor, that is cost, means how much cost required that particular material handling for selection. So that's it. Thank you.